Hello, good evening, everyone. How are you all? Am I audible? Hello, I cannot see your messages, so please unmute yourself and respond when I have started the class. Hello. Anyone, can anyone respond whether I am audible or not? Okay, fine. So let's start the session. This is the live problem solving session of the Joy of Computing using Python uh, of week 6. I am Vikas Pandey, a PhD scholar in IDRP Space Science and Technology at IIT Jodhpur. Okay, so this is something about me. So the this is my site. This is classroom link, and this link is the one where you can join every week, Thursday 6 to 7 p.m. And all the videos of the previous and the forthcoming sessions are available on my YouTube channel here. Okay, so moving forward, first let me ask you: do you have any question related to this week? Do anyone have any question related to this week? Okay, I assume none. Then let's move forward. And as I expect everyone to be speaking up, so please don't be shy and speak up and interact in the class. This class is meant for live interaction, not just to demonstrate, because this thing can also be found in a recorded lecture. But this is a live session so that you can ask, you can respond, and we can have a discussion regarding it. Okay. So let's start with this question. Question one. So what does this code does? So as we have seen, import string. Okay. So can anyone tell me what is the function of this import string? Please respond. Don't be shy. You can unmute yourself and speak up. Someone like
Function will be imported.
yes, the string library will be imported. Okay. Then the next one we are doing is def. What is the function of this? Anyone can tell. What is the function of this? Def. Let me ask someone. Bhiva Singh, can you respond?
Yes, sir.
Yeah.
Def is the keyword used to define function.
Very good. So we are creating a function here with the name shift, and here you see there are two inputs, word and value. We are taking two inputs in this function. Okay. So now what is this doing? The next one, letters equals to string dot ASCII lowercase. See here, we are not doing ASCII characters, we are doing ASCII lowercase. So what is being done here? Please be fast, don't hesitate. Don't worry, even if you are wrong.
ASCII underscore lowercase, it will convert uppercase letters into a lowercase.
Okay. Anyone else who thinks different, or everyone agrees with her? Rayoli, can you respond?
Yes, sir, I agree. It's going to convert letters into lowercase.
Okay. Here, see, here we are importing string library first. Let me clear this. And then what we are doing is that from the string library, we are using a function skey lowercase. It is not used to convert. It is used to take all the lowercase from A, B, C, like that till Z. Okay, all the lowercase letters of English alphabets will be taken from it. So letters will be equal to then in quotes A, B, C, D, E, F, like that. Okay, clear?
Yes, sir, understood.
Okay. And then in the next line, line 5, what we are doing is new equals to a blank code. That means it is having nothing, just we are initializing a variable new. So for I in range, length of word. So you see word and value, these two things will be taken in. So it will check the length of the word. Suppose it is like computing. Okay. If we are taking computing. So how many letters are there?
9.
9. So the value of here will be, what will be? 9.
9.
Okay. So ideally we are going to loop one by one. One by one we are going to take the words. Okay. So word first one in letter. Okay. So if this word is in letters, okay, means it is in lowercase. If the specified first like C is in lowercase, then index equals to letters dot index of word I. Okay. So it is what it is doing. It is taking the value like suppose we are getting C. What is the value of C here? It is at the third position in A, B, C, D. Okay. Uh, and suppose we have put the value as 4. Word as computing and value as 4. Then what it is going to do is that it is putting new equals to new plus letters and index plus value. So it will do 3 plus 4, that is 7th. So it will E, F, G. It will take G. Instead of C, it will be G then. And then this thing will continue. And this will only be done when it is in lowercase, not in uppercase. Okay. So which of the following can be the correct answer?
First option.
First option is shifting every letter in the given word by the value. Like if we are taking the value in the case of A, B, C, like A is 1, B is 2, like that. So we are shifting all the values by some specified value. Okay. So let's check. Let's see. Okay, just a minute. Let me reconnect. I think I got disconnected from you. Okay, we were here, right? Okay, so let's try. So here we have the function as we saw, but we don't have, we are not running it here. So let's run it like we are saying print. Let's put all small letters in it. Let's shift it by 2 only here. Okay. Let's run this and see. Are you getting it, or is it tough to understand? Everyone,
It's understandable.
yeah.
Also,
So
sir, can you link this notebook? Can you give the link in the chat box?
link of the notebook, since I have not shared it, it is not public, and it is from my organization email, so you will not be able to access. But all the slides I am putting in this NPTEL, like you will find it there, and all the prompts are there in the slides. Okay, so don't worry. You will have to write a bit, and I will try to put a copy of this notebook in the in that link also, in that folder. Okay.
Okay, sir, that's okay. That's all right. I'm also typing with you.
Yeah, yeah, sure. Anyone else is having any problem? So you see here, C is being shifted by 2, D and E, so it becomes E. O is shifted by 2, so it becomes Q. M is shifted by 2, it becomes O, like that. Okay, so the words are shifting here. We can try doing some other words also, like in this case, if we put something like hello. You see, it here is H is again shifted to E is shifted by 2, like that. But the same thing, if we are going to put here something capital letters, I doubt it will run. Like H will not change since it is not in lowercase. Here you see lowercase. We're only taking the lowercase letters. Okay, so the first one is correct one. Okay, now let's move to question 2. What will be the output if the input is joy of computing? Of computing, here actually I have written here small, but actually it will be capital OF. Okay, so let's see. Can anyone try to explain what is happening in this, and then we will discuss what can be the answer of this code. Please, please skip up. Like, please speak. Don't be shy. Even if you don't say it correctly, no one is going to deduct any mark. Okay, please speak.
Sir, in this, the lower caps are shifted by 2 positions
Hmm.
ahead,
Hmm.
and the upper caps are shifted by 3 positions.
Yes.
So the
So
third option should be right.
third option should be right. Let's see. Anyone else who have not understood it, why it is happening? It is very similar to the previous one, but in previous one we were only shifting the left one, like lowercase one. Here in this case we are shifting both uppercase and lowercase. So here we are saying if the character is in lower, then we are shifting it by 2 up, and in case it is in lower, in upper, we are shifting it up by 3. Okay, so uh, the first thing, easiest thing is to check this one, because this is the smallest word, right? So OF, both of them are capital. So capital is being shifted by 3. So that will be O is shifted by 3. So P, O, P, Q, R. Okay. So it is changed from O to R. And I see there are 3 options with R. Okay. Then let's check F. So F is again capital. So F, G, H, I. So F should be shifted to I. There are 2 options here also. Then what next? We can try joy. Okay. So J should be shifted to what value? Actually, joy is same only in both of these cases. So we cannot go for that. This is also same. So we can see this. The. Okay. T H E. T is capital. So it will be shifted up or down.
Shifting up.
Shifted up. So what it will be? T
W.
U V W. So T will become W. Okay. So I think option C should be correct. So you were right.
Yes, sir.
Okay. Let's check. Okay. So I have already made the program. Let's run this. We can try some other words also. You must understand the logic. And can anyone tell me why are we dividing it by 26 here? Like why we are doing the modulus 26 in line 11 and line 15? Let me ask someone.
Because
Yeah,
the alphabets in lowercase and in uppercase are 26 each.
yeah. So we are rotating. Like if Z is there, so two
After
more
Z,
than,
A must come.
yeah, A, B like that. Okay. So you see, the one which we were expecting is coming. Okay. So this is the correct. Now, okay. So in this week we have learnt about recursion, which is a very important way of doing some programming in an efficient way. So which of the following will be the correct one? Recursion increases the speed of the program, decreases the speed of the program, speed of the program remains the same. It is easier to understand than non-recursive programming. So which of these are correct?
I think, sir, option C.
C remains the same. Okay. Anyone else? Bharat, Bharat Aman. Let me ask someone. Yeah, please speak up, Bharat. I cannot see the messages. I hear that there is some message, but I am not able to. Please unmute yourself and say. Okay. Then, yeah, Bijendra Rathod.
Sir, it will increase the speed of the program.
Uh, how?
Not sure, sir.
Okay. See, generally in this case, yes, it increases the program. Uh, it increases the program in the sense it does all the calculation at once in later cases. And the last one, recursion is easier to understand is wrong. The thing is that actually it is a bit like not very intuitive in the sense you have to think a lot for making the recursion programs, but the program is shorter and easier. Okay. In some cases, when we go to a large number of recursions, you might see that the program, instead of running, it just stops. It is not because of speed, it is because of the capability of your computer. Okay. In recursion, what has to be done? That suppose we are trying to find the factorial. Every one of you are aware with factorials. Like suppose we want to find 4 factorial. So 4 factorial is ideally 4 multiplied by 3 multiplied by 2 multiplied 1. So,
Yes, sir.
so what we do is that we take the number 4 and we say go for it can be said 4 equals to like 4 multiplied by 3 factorial, and 3 factorial can be written as 3 multiplied by 2 factorial. Similarly, 2 factorial can be written as 2 multiplied by 1. So at last, one thing we know is that 1 factorial is 1 itself. other things we just keep. So we keep accumulating these values and then we do all the multiplication at once. So your computer on which this program is running should be capable of keeping all those values at once. That means it should have that much of memory and this thing. But actually increases the speed because we are not going to do multiplication again and again and again. All the things are being done once. We are not going to run a loop. Okay. So recursion actually increases the speed, but at the same time it uses more resources. Okay. So it cannot be run on a capable computer or something. Anyway, nowadays the computers or even small tab and mobiles are adequate to run such programs. Okay.
Okay, sir.
Okay. Now we will be solving more questions of recursion. So what will be the output of the following program? Def is we are defining a function and we are naming it as recursive, and we are taking any number as an input, and what we are doing is that if number equals to 1, return 1. It is very similar to what I was telling, factorial. Okay, that 1 we already know, if 1 factorial is given, it is always equal to 1. This we know, and in any case of recursion, a base value is very, very important. A base where it has to stop, that must be known. Okay, and then for all other cases, what we are doing is return number multiplied by number minus 1. Okay, so can I tell what is it doing?
Calculating the product of the first 10 terms.
First 10 terms. It is just
Factorial.
Kind of factorial, yes. First n terms. So calculating sum of first n terms. Let's try running this. Anyway, we have already got the idea, right? So what I have done is that along with this, I have put one more line where we are running this with an input. Okay, so I'll be running this with an input. So suppose we are putting something like 10. So it is putting the sum of first 10, sum or multiplication.
Sir, it is a multiplication.
Yes, it is multiplication of first n numbers.
N into n minus 1.
N into n minus 1 only, not sum of n numbers. So how it can be done to have sum of n numbers? Actually, I think that part is actually it should be something like this. Okay, then it will be the whole thing, like then it will be the factorial.
Okay. So earlier it was just 10 into 9.
10 into 9 only, nothing else.
But right now it's the factorial of 10.
Yes, right now I think that thing I missed there. Like while writing the program, I missed it. But
now it is the factorial.
Yeah, now it is the factorial. So what it is doing is that every time, like suppose I am putting 4. So 4 goes in here. Let's discuss here. Okay. So here it will be recursive and then num minus 1, right? Num minus 1. So what it is doing is that suppose we are putting 4 here. So it is first checking if it is equal to 1. It is not equal to 1. So in first go, what it does is that it says return num multiplied by recursive of num minus 1. So it is again from here, it is again going into a loop. But in this time, case num minus 1. So 3 goes here. So it keeps 4 multiplied by, I am just putting 3. Okay. So in second step, then again this whole loop starts. 3 goes in here, it checks, it is not equal to 1. Then it goes next. So it says 3 multiplied by recursive of 2. So it becomes 4 multiplied by, this is expanded to 3 multiplied by recursive of 2. The same thing again. Next time what happens is that, next time it happens, it expands as 4 into 3 into 2 into recursive of 1. But in this case, when this recursive of 1 runs, it goes into the loop and it goes here.
It just
and
returns 1.
It returns 1. So here, this is called the base condition. Okay. So it is replaced by 1. So at once this whole, all the values are just kept stored, and at once this whole multiplication happens. And we get 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay. So this way it is faster for the processor to run. Like in one step, all of these are done. Okay.
Sir,
So
if
yes.
So how the value of num is changing?
Yeah, what you are saying, Birendra?
How the value of num is changing, like 4 to 3, then 3 to 2. By this
Yeah, because here we are putting recursive. Let me show you. Here we are putting recursive of num minus 1, right? So here we are actually making it minus 1. So we are reducing it every time here. That is why it is reducing. Every time, like it is storing and is reducing. Got it? Hello? Yes, and someone else was also asking a question.
sir, this else return, second return is working as an else.
Not as an else. You can we can even put else here, but what happens in case of functions, that as soon as it encounters return, the function stops there only. So we don't need to put something like else or something.
Right. Right, sir.
Yeah, someone else was also asking a question. Please.
Yes, sir. Can we
Yeah.
put any other base condition? For example, here it is 1. Can we put 2 or 3?
Yes, we can put anything.
And then it will stop at that number.
Yeah, stop at that number. But certainly in that case, it will not be a factorial, right?
Yes, sir, of course.
Yeah, and Bharat, you were also asking some question. Hello.
He has written a text on chat,
Yeah.
sir. Why recursive used in print at the end?
Okay, there we are in line 8, you say, right? So in this case, what we are doing is that we are calling the function, this recursive function. In this case, we are calling the function recursive, because this is just a definition. Line 1 to 6 is we are defining how recursive will work, but in line 8, actually the program is being run. This is the main part of the program, you can say. So it is asking, like it is asking an input from us and giving it to the function recursive, and then recursive is calculating it and it is giving the output print. Fine.
Would you please elaborate a little regard what is calling of function?
Which function?
This recursive, it is a kind of calling function.
Wait, let me explain.
So this recursive is calling function.
Calling function is something like calling is not a function, you can say. Like we write print. Okay, print something like hello. Okay. So what happens is that this print, the Python interpreter knows that print, what it does, whenever I encounter print, whatever is written in bracket, I have to display it. Okay. So from where it knows this print? Because this print is defined just like we are defining here. Na? If you check the original library, general library of the Python, you will find such definitions do exist for all the functions, all the general functions we are using. But in this case, recursive is already not defined inside our library. So here only we are defining recursive. Okay. And many a times you will see that in many cases we don't put this definitions like function definitions inside the main program. What we do is that when we create two files, one in which we will define all the functions, it works as a library, like we are doing import string, import this. So we will just import that file and all the functions will be inside that, and we will be running those functions inside our code as if they already existed.
So that will shorten our code.
That will shorten out code, and this thing is mainly done when we are going for some big programs where like 4 or 5 functions are being used again and again. So we are not thinking of like just using it for this program, and that function is to be used in 4 or 5 programs or 10 programs. Then we are going to put that in a single file, and we are using it just like we are using a library. So it is like you can say we are creating a library there.
Yes, sir.
Okay. Clear?
Yes, sir.
Okay. So, yeah, in this case, as I said, here recursive should be written, right? So it is calculating the product of first n terms then. Now let's move on to this question. Here, this is similar to previous one. The only difference is here that it is taking a list as an input. Okay. L is a list here. And the advantage of Python is that we don't need to specifically define what is going inside there. In many programming languages, you will see here we have to define like int, L, float, or such things. Okay. But in this case, in Python, the advantage is that it automatically understands what, if I am just writing L, it will automatically understand when it is treated as a list here, it will automatically understand that it is a list here. And if you don't give a list as input, it will give you an error. Okay. So what it is saying, if length of L is equals to 1, so when the list has reduced to one single value, then return that value. Else, what have to be done? Return L square bracket 0. What will this do? L square bracket 0.
It means the element of L at 0th position.
0th position. So it will give the first. Okay.
Yes.
If we are giving this first one. And then it says recursive 1 till end. Nothing we are writing, so it is till end. So what it is doing is that it is saying 1 plus this whole list like this. And
so the answer is 55.
55, yes. So it will just go inside. Answer is not important here. Understanding here is important, because recursive is something, though seeing the program you will be able to understand, but when you have to write a recursive code, it needs a bit of understanding and thinking. Okay, the same thing can be done with a simple like different code also, but in that case the code will be a bit bigger, as well as this whole thing can like here we will use a loop kind of thing, as well as when we will run that, it will take actually more time for the processor to run the same program if it is done non-recursively. Okay. So it is breaking it here, then it is going again. So this time 2 will be left, and this will, so this continues till the last one is, and when 10 is left, it returns that value itself. So 10 multiplied by 9 multiplied by 8 multiplied by 7, everything till 1 is done. So it is 55. So let's check whether our understanding is correct or not. Okay. Yeah, I made the program. So it is 55, right?
Yes, sir.
Now, if we are going for something like removing this, it will be 45, right? So this is working fine. We can even not necessarily give it in sequence. We can give it something like 7, 9, 10, 11. Okay. Still, it will give us the output 21 plus 16, that is 37, right? So now, yes, this one is a tricky question. What will be the output of the following program? I'm not going to help you all. First you people think, then we will discuss on this. Very similar to the previous program, but there is a trick. Yes, Shreyasi, why you think A? You calculated that value.
Option A, sir.
Yeah, what are you saying, Viva?
Sir, in this function we have L minus 1. So in that case, we will traverse list from backside from 10, 9, 8, 7, 6, 2, 1. First
Ah.
at star recursion L of colon minus 1. So it will start from n to first number. Multiply 10 into 9 into 8 into 7. In this
Okay.
way.
Okay, so if you do that one, it gives us 3628800.
Yes, sir.
Okay. Anyone with another answer? I expect many answers for this. Yeah, anyone who thinks like
Sir,
it will. Yes, yes, Birendra.
this return value, this will start from -1. The end value is -1.
My,
So
-1 is, as we have discussed earlier also, na? The indexing goes like this: 0, 1, 2, 3, like that, right? And when we are counting from negative indexes, like from the right hand side, it is -1, -2, -3, -4, like this. Okay. So here we are, what it is doing is that it is saying we are storing the first one and then multiplying it with again the recursive of from starting till -1. So it will take, just leave this, leave one, and then it will continue.
it means it will start 10 into then
Yeah, 10 multiplied by 9 multiplied by 8 multiplied by 7, like that. But where will it stop? Yes, Aditya, you are trying to say something?
What is asking?
I think it's zero index.
At
One.
zero index, it will stop. Okay.
Because it is a list.
Okay. But do you know an empty list? Like if we have an empty list and still it will have the zero index.
In that case, it can run for infinite.
Yes, it will go into infinite loop. You people are thinking everything, but the thing is that as you must have studied in your basic, like in class 2, 3, I think it is taught nowadays that computer is a very dumb machine, right? It does what we instruct, nothing more, nothing less, right? So here we are not giving it anything to stop. Like in the previous case, you see here we had a base base or stop value. Okay, in all the recursive functions. This is an important part of it. It must have a end value. Otherwise, it will continue in a loop. Okay. So, so
So
it
we
will,
need a basic condition here.
yes, we need a base condition here. Without base condition, this will keep continuing. So we will have to put something like if length of this L is equal to 1, like we did in the previous case, right? This thing, this thing, if you put, it will work fine. This, if we just copy this and put it there, it will work fine. Let's see if it actually runs into an infinite loop or not. You see, in fact, in my case, it will just try to run sometime and then it will give some error because this Google Colab library cannot handle it. See, it is saying index error because list index out of range. It goes on, stop. Like it goes on, it tries to go beyond 0 also, which in this case it is not working, right? So if you are running on something like less intelligent computers, it will keep on running and it will not stop. You will have to forcefully stop it. So what will be the solution here? A better way to do it will be, yes, length of L is equal to 1, then okay, let's run this. Now the same code should run. Okay, now we are getting the value your people were saying 36288800, right?
Understood, sir.
Okay, sir, earlier it was not giving because of this, we haven't written this length is equal to 1.
Yes, we were not putting the stop value, and that is why this uh, question was about your understanding about recursion function only. A recursive function can never run without a base value, base condition. Base condition is an important thing. Base condition is an important thing for any recursive program. For a non-recursive program, it can stop, it can work fine without a base condition. But base condition is very, very important in case of recursive. It is because something you are saying a loop will loop inside itself. Here, loop inside loop, and that also the same loop. Okay, so this will keep calling itself again and again till it is stopped. So there must be some stop. Fine.
Right, so
This is a very important thing. You must remember always whenever you are dealing with case of recursive function, it must have a stop. Okay. Now, in the previous class, we learned something about binary search. Remember, we made something like how to search, divide the thing in half.
Yes,
Like
sir.
suppose, and one question again. Binary search can be applied on what kind of a list?
Sorted list.
Sorted list. Very good. Okay. Sorted list one. Okay. So, what will be the method of using? Like here you see why we are doing it here, because here also recursion can help, because the same way of functioning like dividing, and checking whether it is there or not. This thing is done again and again till we find the value. Okay, that is why we can use recursion here. I have done it like this. You can try something else also, it's your wish. Okay, so I have just created a function. I have not put the value. So I am taking a list L, find, start and end. Okay, there are 4 things here. So it is first finding out the mid value. So start plus end divided by 2. So at first the start will be the starting value like 0 and end will be the length of the whole list. Okay. If start equals to end, then what has to be done? If we the list is with only one number, so we will just check if it is equal to find, that is what we have to find. We will return the value, the index, that is wherever we have read, else return -100. -100 is something like we are saying error. Okay, -100 is here used to denote error, that we are just raising an error that that number was not found here. Fine. Then we are saying if mid. In this case, when it is equal, like we have only one number left. But if we are dividing the whole list in half, and we are getting that the value at the middle itself is equal to our find, we just return the mid index. Okay. Else if our find is more than the mid value, mid index value, we will again do the binary. That means we will again run this whole thing. But in this case, find will be same. But here we will say we'll start with the mid plus 1 till the end. Like we will start from here till here. Okay, we'll leave that. Else, what can be done? Find is less than L of mid, so it will do this. So it will start and then mid -1. Clear or confusion in this?
Excuse me, sir.
Yes, Aditya.
Sir, what does this find value mean here?
Find is suppose we have a list like this. Let me go to the previous. Yeah, we have a list like 2, 3, 4, 8, 11, 14, 17. This is ordered list, right? Sorted. Now someone says, what is the position of position of 8 in this list? Okay, so if we see as a human, it is easy for us, right? We can see 8, but computer have to go sequentially. Okay, so 8 like this is the list L what we are showing here, and 8 is the find. Okay, 8 is the find and start is this one, end is this one, index 0, and here in this case 4, 7. Okay, 6. No? Clear? One more thing we can do here is that which I think has not yet been taught. That's why I didn't write. We can put the start by default as start equals to 0 and end equals to length of L. That means if no value for start and end is given, it will automatically take those values. Start equals to 0 and length equals end equals to length of L. It will automatically take those values.
Upon writing that, will it shorten our code?
It will shorten our code when
we write start equal to 0 and end equal to
yes.
length of L.
it will write in the code only when it will shorten the code when we are running the code, like when we are calling the code, like calling this function. There we don't do put the start and end values always until unless we have some specific values. Okay,
Okay. Okay, sir.
so we can try this. Let's. I have made the code, but I have not made that calling function. So let's say. Print. And how will we call this function? Binary. Is it correct when if I write it like this?
No, sir.
No. Why?
Please capitalize the binary.
Yes. In case of Python, we have to take care of like uppercase, lowercase. Okay. So we are giving a list. Suppose 2, 3, 5, 7, 10, 12, 14. Okay, 20. That's okay. Then the next thing we have to put is that we are putting find. So what we have to find? Let's say we are trying to find 12 here. Okay. If I run this code, it will give an error. Why? Because it is saying
Because we have not given start and end.
yeah, start and end is not given. So in this case, we can give it like let's put it as 0,
10.
2, 3, 1, 2, 4. We have something like 7, right? Let's run this code. Okay, that bracket has to be. Okay, so it is giving us the position. It is at the 6th position. But this, if we put 0 equals to L. Okay, so even in this case, it will run. Okay, sorry. There it will not run because we cannot run a function. Yeah. In this case, we will have to specify some number. Okay. So ideally, we can put that end here. Something like we can modify it a bit like this also. Okay. This will still give error. So even if we don't put 0 and 7 there, but 4 were given, right? Retake 2 to
सर
3.
हमें चारों आर्गुमेंट देनी होगी.
No, we have to give 3 arguments, no?
तो सर एलिफ में प्रॉब्लम होगा ना स्टार्ट एंड एंड में.
Okay, every time end is changing here. Yes, that is why it will be an issue. Yes. So we cannot use this length of L inside that, but yes, start we can give. Start we can skip. Okay. But in this case, it will be difficult out that, right? So it is better we stick with start and end here. But you can specify this default values there. If you put equals to something, you see here in this case the error says binary takes 2 to 3 positional, 2 to 3, because 2, even if you give 2, it should run. But here there was issue with that running in next loop. Okay, so it was it was giving problems when this thing, the next line, I think here. In line 14, it was giving problem because here an end value is again given. That. Mid -1. No, it will have issues. It will not run. Because we have to specify, because our end value is also changing every time. Okay. Sorry. So there can be many ways. Even you can do it without recursion, but in that case you will have to do it again and again. And in that case, the value, like the program will depend on the length of the program will depend on the length of the list given, the size of the list, how many times you have to do. You will have to loop according to the length of the list. Fine. You people got it, or there is confusion?
Yes, sir. Understood.
Now you see, in this case, if we would have tried to find something which is not there, like instead of 12, suppose I am trying to find 4, which is not here. Okay, so it should ideally give -100. Why? Because that is not found here. It is running, trying to find all options and stops because it is not getting anything and it goes -100. So the error has been taken care of also. Okay, so what will be the output of the following program? In this case, the first thing, whenever recursion comes, always say there is a base value or not. Okay, so it is taking a list in, and if length of L is less than 6, so when the list size is less than 6, that is 5 only. Okay, so the last value has to be returned. Okay, return L -1. So if a list is there, so last value multiplied by the list. Okay, and then this whole thing again runs till it has length of 6 and the last value of it is returned in that case. So what will be done? What will be the output of this program?
I think, sir, B.
B. Return the product of element from first to fifth index. Okay. Anyone else?
Sir, A.
A. Return the from fifth index onwards. Okay. Anyone with answer C or D? Yeah. Tracy, yes. Can you explain why? Please try to visualize also. Okay. So let's see. Tracy, take some time and please explain that why you think it is first to fifth index.
-1, that's why in the reverse direction.
Yes. -1 is
And
the
maximum it
last.
will be length will be less than equal to 5. That means 5. So 5, 4, 3, 2, 1, 0.
Okay. But see, in line 3, we are saying if the length of this length of our list becomes less than or equal to 6, we have to stop there. And we just take the last element of it, this one. Okay. So rethink about it and let's discuss. Okay. So what it is doing, again, let's take an example. Okay. We have something like 1, 2, 3, 4, 6, 6, 7, 8. Fine. It goes inside here. L equals to this much. So it first checks if length of L is less than or equal to 6. Is it true or false for this case?
Uh,
It's
it is
false.
false here. Just
It's
false.
false.
It's
Length
false.
is more than 6.
Yes. So it is false. Tracy, are you getting it? Hello? Tracy, are you getting it?
Yes, sir.
Okay. So this condition is false in this case. So what will happen? It will go to line 6. Okay. So it takes the last element, L minus 1, as you rightly said. Okay. So it takes 8. So it just stores 8 and it says again multiplied by, so we are putting a star, recursion of L from starting till minus 1. That is, it will take this part. Always remember, whenever we are putting the ending position, it will take one less than that. So it will reach till here only. So it becomes something like recursion of 1, 2, 3, 4, 5, 6, 7. Okay, done. Now the next thing it does is that again this whole thing goes and it checks in line 3. In this case, is it true or false?
True.
True. What is
Again,
the
false.
again false because
It's
it is
false.
still 7, right? So it is again false. So what it does is that in this case again it takes the last value, that is 7. So it now becomes 8 multiplied by 7 multiplied by recursion of 1, 2, 3, 4, 5, 6. Fine. Now it is again going inside. So in this case, let's take another color, right? Yes. So yes, Resi, please say in this case, is it true or false? The line 3.
Again, false.
Again false.
It's
See,
true, sir.
true, because 1, 2, 3, 4, 5, 6.
True.
We have the length is 6 now. So
Less
it
than
is,
or equal to 6 is the
yes,
condition.
less than equal to, not just less than. So it is true in this case. So it is not going to run any further. It will just return the last element of it, that is 6. So our value will become 8 multiplied by 7 multiplied by 6. Okay. So, and it will give us the product. Fine. So in this case, the index of 6 was 5. 0, 1, 2, 3, 4, 5. Fifth index, right? So fifth index onwards, it will multiply the thing. Getting it now? Those who were thinking it to be B
Yes,
or
sir.
C. And C, what is the confusion here is that it is not saying the sixth element. Okay, it is saying the fifth index. Okay, so many of you might still confusing A and C because in one case it is saying fifth index, one case it is saying
Index
sixth
will
index.
start from 0, na?
Yes, index starts from 0. That is why,
And element 1.
yes, element will start from 1. That is why it is from the fifth index. Okay, and sixth element. Fifth index and sixth element. Okay, clear?
All right, sir.
Yeah. So we can even run this code. Let's try something like we'll run it first. Okay, so from my understanding, it should multiply 6, 7, and 8. Okay, let's see. Okay. What it is saying?
The smaller brackets.
Acha,
Bracket
one
after recursive.
bracket after recursive. Yeah, one bracket I have missed. No? And then it should go till end. Yeah. So is it correct? Should I open the calculator?
It's correct, sir.
It's correct? Correct. Okay. So if we put something here like 8 and 8, I remember that. So I think I can verify. Yeah, 512. So it is taking the, so 1 is our 0th index, 2 is first index, 3 is second, 4 is fifth, 4 is third index, 5 is sixth index. Okay, not 6, sorry, fourth index. So 8 is the fifth index. So it is starting from fifth index going till the end, right? So it returns the product of elements from fifth index onwards. Clear for everyone, or is there still some confusion?
Clear, sir.
Okay. So yes, this is something I have already told you many times. A program
False.
which is cannot be written in recursive manner. Yes, so it is false. It can be written, but we have some advantage with recursive, and it is very important to understand that all recursive programs can be written in non-recursive manner, but all non-recursive programs cannot be necessarily be written in recursive manner. Okay, but when we are able to write in recursive manner, it has some advantages. Fine. So let's come to the last program, which is something of interest for every one of us. Okay. So can anyone tell what will be the output of this? I will explain the program first. Let's then discuss. Okay. So it is taking a number in. Okay. And it is saying if number is equal to 1, print a star. If it is 1, print a star. And return. Return means at this point itself, this program will stop. If number is divisible by 2, modulus 2, so what it has to be done? So if it is not equal to 1, then
to print star number of times.
Yeah, start that number of times if it is an even number. Okay, and then recurse with number -1. So here a loop will start. Else, if it is not divisible, so it is odd. In that case, it just have to do nothing but again loop with decreasing the value. Okay, and we are giving 10 here. So let's understand one by one. When it is 10, when the value of is 10, so what will happen in this case? Line 3
The
will it
star will
run
be printed 10 times.
10 times because it is even. So like that 10 times. Then what happens? It becomes 9, right? So in this case, what will happen? Can anyone tell? Hello, am I audible?
So it will go in the else loop.
Go to the next loop without doing anything. So it will just decrease. It will become 8 and start again. So in case of 8, what will happen?
Star will be printed 8 times.
8 times. Okay. So earlier it was 10 times. Here it is 8 times. Okay. Then again it will loop into 7. Again 7 is not going to run because it is odd. And then it will go to 6. Like that. So you see every time one line is being skipped. Right. And then 6 times it will be printed. Then this value once will become 1. And when it becomes 1, what will happen? A single star is
Like
present.
a single star.
1 star.
1 star. So what will the pattern look like? First it will be 10 stars, then 8 stars, then 6 stars, 4 stars, 2
Inverted
stars.
right triangle.
Yes, and then lastly 1 star. Okay, I have taken the output of it. See, it looks like this. In fact, such programs you can try a lot. Like, in fact, you can put different values. You can try to make different patterns. A lot of patterns can be made using such programs. Okay, let me show this 10. You can see. We can even try something like, let's say 11. 11 will still give us the
Also print like 10 only.
same output. Yes, but if we go for something big like 20 something, it will be a bit bigger. Okay. And it is skipping one line. If we want to print even this line, like if we just remove this if else thing, we just put this line 8 to 10 after this line 5, it will just print all the numbers till end, right? So such things can be made using this, and a lot of patterns can. So seeing this, you can see, say what is the use of this, right? Printing stars or dots or these things have no meaning. But if you see the screen on which you are seeing, if you see it closely, you will see there are small dots on your screen, right? All the things you see, if you zoom it or you take a magnifying lens and try to see it, small dots are on the
Pixels.
screen. Pixels, yes. So every pixel, when we are seeing this, na, you see this 10. Actually, it is something like small boxes filled with this color here. Okay. So to make that, if we have the understanding of patterns, like how to we program that how some specific places are filled, we can do this thing. In fact, at the back end, how these things are being displayed on our screen, even how my face is being transmitted to you, is that colors are being transmitted to your computer or mobile, and it is being processed at which dot which color has to be there. And sometimes you might see that though my face is going like that, but at your place it might be frizzed, or it might have some different shapes, like some curves can be changed. That is just because of some programming glitches that is being happening due to not receiving the complete program or not receiving the complete data. Okay, so making patterns is quite an important part of this whole graphical, like when we go for graphical, uh, showing something graphically or making something, you can make square, rectangles, and a lot of things using such patterns. Okay, clear till here?
Yes, sir. Clear.
Okay, so you people have any other questions related to this week? Okay, so I hope that's all for today. See you all in the next class. Okay. Thank you all.